All right, we've got our first example of an integration by parts problem here. This is a classic integration by parts problem, x times the sine of x, which we don't know the antiderivative of, and so we need to do something to find that antiderivative. We're going to try this formula out. This is the integration by parts formula. We've got our original integral, x sine of x, and we're going to use the formula to write that in terms of a new integral. All right, we have an equality here. We've got an equivalence between our original integral and this new expression involving a new integral. So we're going to hope that the new integral we get is easy to deal with. Now the original integral in the formula, the integrand is broken up into two functions, u of x and v prime of x. So we have to make those assignments here. And this is somewhat arbitrary, especially at first before we've built some intuition into these problems. So we're going to take our original integral and the parts of that integral, we have to make those assignments. The u of x part is x, and the v prime of x part, we're going to say, is sine of x. Now we could have done this the other way. We could have said u of x is sine x and v prime is x, and we can see where that takes us. That's going to take us into a dead end, actually, and I'll show you that in a separate example. But this is the right guess for how to split up the integrand into parts. So these are the parts. U of x equals x, v prime equals sine of x. And now we want to use this formula. In order to use the formula, we need a u prime and we need a v. Right now we have a u and a v prime. So we got to do a little bit of calculus in order to use this formula. So for the new integral, we're going to need u prime. That's an easy derivative. U prime is 1. And we need v from v prime. So the antiderivative of sine x is minus cosine of x. So we took a derivative from u to get u prime. We did an antiderivative from v prime to v. Now we have all the pieces for our integration by parts formula. So our x sine x dx integral is equal to u times v. So I have u and v here in this little table I made. That's negative x cosine x minus an integral of u prime, which is 1, times v, which is negative cosine x dx. So there it is, simplifying the signs a little bit. This is minus x cosine x. A couple of negatives gives me a positive, plus the integral of cosine x dx. Remember, the hope was that our new integral was easier than our original integral, and that is the case here because we know how to integrate cosine of x. So in the end, we do that integral, that antiderivative, and we get sine x plus constant of integration c, and we're done. That is the answer. That's the antiderivative that we were looking for through the integration by parts process.